Question 31. The diagram shows a side view of a water wave at a particular time. The diagram is drawn full size. Which statement about the wave is correct? Well, water waves are most certainly not longitudinal, so A and B is ruled out. C, the wave is a transverse and the frequency can be measured from the diagram. No, this is a common misconception. The wave is certainly transverse, but the frequency cannot be measured from the diagram because basically frequency is the number of waves in 1 second. And there's nothing on this diagram that suggests that this diagram, though, these waves were drawn over a period of 1 second. What we can do is take the wavelength, but we certainly cannot take the frequency. Therefore, the answer is D and not C. Question 32. Different parts of the electromagnetic spectrum are used for different purposes. Below are 4 statements about parts of the spectrum. Well, I hope you can see that statement 1 and statement 4 are correct because radio waves are used to transmit television pictures from satellites to Earth. No, that's another misconception. It's not radio waves that do that in statement number 2, it's microwaves. See, in the olden days where we had terrestrial TV, and by that I mean local channels, so channels that are local to your country, those would be transmitted by radio and TV, well, namely TV waves, which are fairly similar. Satellite TV, however, where we get to watch sports and movies, etc. from many different countries, they are transmitted by microwaves. And statement number 3, ultraviolet waves are used for intruder alarms. Nope, that's infrared. So only statement 1 and 4 are correct. Therefore, the answer is B for ball. Question 33. The diagram shows a water wave approaching a barrier with a gap. The wave reaches point P. What is the name of the effect that causes the wave to reach point P? It's diffraction. When you pass through a gap or any obstacle, waves will bend around that gap or obstacle. And if the gap is small enough, the diffraction will be maximum. And if the gap is big, then diffraction will be minimum. In other words, it looks fairly straight with curved edges when diffraction is minimum, and the waves are rather curved if diffraction is maximum. Question number 34. Which row states 2 properties of sound waves? Well, basically, yes, they can travel through a medium, which is a solid, liquid or gas. In this case, A and B are ruled out because sound cannot travel through a vacuum. And sound waves are longitudinal waves, so the answer is C. Sound waves are not transverse, so the answer cannot be D. Question 35. The diagram represents a water wave. Which row shows the amplitude and the wavelength of the wave? Now, amplitude is the maximum displacement from the rest position. In other words, from the middle to the top or from the middle to the bottom. So the amplitude here is 2. The wavelength is the length of one wave, and that 4 meters is actually showing you the wavelength of 2 waves. So the amplitude is 1. And the wavelength is 2. So the entire displacement was 2, so the amplitude is just 1. And they're showing you 2 waves with a wavelength of 4, so the wavelength is actually just 2. The answer is A. Question 36. A man is holding a starting pistol, stands 640 meters away from a spectator. The spectator hears the sound of the starting pistol 2 seconds after seeing the flash from the pistol. Using this information, what is the speed of sound in air? Well, distance equals speed times time, and here speed equals distance divided by time. So 640 divided by 2 gives us 320. The answer is B for ball. Question 37. Which row correctly defines a type of wave and gives a correct example? Well, the answer is D, because it's transverse, which is perpendicular to the direction of travel, for example, radio waves. Let's look at why it's not the rest. Longitudinal waves are parallel to the direction of travel in A, but radio waves are light waves. So the first two columns are correct, but the last column is not. So it cannot be A. In B, longitudinal, the middle column perpendicular to the direction of travel, well, that's not correct for a longitudinal wave. And longitudinal waves are certainly not light waves either. So the second and the third column, with respect to the first column, is not correct. And let's look at C, transverse, and the middle column parallel. Well, no, those are wrong with respect to each other. And light waves, well, the first column and the last column are correct for C, but the middle column is incorrect with respect to the other two. Only in D are all the columns correct with respect to each other. Question number 38. The table gives common uses for 3 types of electromagnetic wave. Which row correctly identifies the wave? Satellite television, well, definitely microwaves. Terrestrial television, radio waves, sometimes known as TV. And television remote controls, infrared, so the answer has to be B for ball. Question number 39. A transverse wave moves along a rope. The diagram shows the position of the rope at one particular time. Which two labelled points are one wavelength apart? So if we look at W, X, Y and Z, to be one wavelength apart, it's certainly X and Z, so the answer is C. W and X are half a wavelength apart. In fact, they're a quarter of a wavelength apart. X and Y are half a wavelength apart. What other options did they give? They gave W and Z. That is 1 1/4 wavelengths apart. And they gave Y and Z, which is also half a wavelength apart. So the answer is C, X and Z. And finally, a plane mirror is fitted to a wall. Which statement about the image formed by the mirror is correct? The image is real in A. No, that's not correct. The image is left to right, laterally inverted. That is certainly correct. The image is smaller than the object. Not in a plane mirror. It would be exactly the same size. The image is upside down. That's also not correct. So the answer is B. I hope you found that helpful.